Hi everyone, and welcome to week 2 of online learning. After this week, we only have 6 more to go. We can do this. So we know how we're going to start every week. We're going to start it with a little comic. So here is this week's comic. I'll give you a second to read it, and then I'll narrate it for you, and then we'll get started with our math. So this week's comment says, what do you call an alligator detective? An investigator. You get it? Ha ha ha. If you don't, send me an email and I'll explain it to you. I hope you get it. So I also made this guy. I was playing around with this app and I noticed that you can do this clip art stuff, so I'm going to try to incorporate that a little more. This alligator saying, should I eat this guy for his bad jokes? I hope not, because I have 6 more weeks of bad jokes to go. So we're going to transition into the math with example 1. Before we start this, I want to explain how this is going to work moving forward. From now on, what I'm going to do is I'm going to give you an example problem every day with a Khan Academy exercise, okay? So this week, what we're doing is every day, you're going to watch one example of this video, and you're going to take your notes on it. The guided notes are in the Google Doc for the week. If you have a printer, it would be great if you could print out your notes and just take your notes on the sheet. If not, that's totally fine, and all you need to do is grab a separate sheet of paper and just take the notes as you go. Okay, so here we go. We're going to do example 1. This week, what we're going to be looking at is we're going to do a little bit more with linear models and lines, but we're going to do more describing them than creating them, okay? We're also going to do a little creating. So, example 1 says, what was the elevation of the plane at 0 seconds and 1400 seconds? So, what we need to do is we need to realize, so we need to see what is going on in this graph. So when we look, we see our x-axis is something. We want to know what it is. Our x-axis is going to be our time in seconds. Do we see that? These labels are going to be super important, and we got to really start paying attention to them. So then we look at our y-axis, and it's the elevation in meters. So what we want to know is what was the elevation of the plane at 0 seconds. So what this is asking for, it's looking for a point, okay? And the point we're looking for is when time is 0. When there's 0 seconds, we want to know what the elevation is. So what we're going to do is we're going to go to time, because we know that it has to be 0 seconds. So we know that at 0 seconds, it's going to be right here, right? That's where it is on our x-axis. But what we care about is where the plane is, and the line is representing the plane. So what we're going to do is we're going to go up from 0 seconds to where our line is. And where is that right there? I'm going to give you a second to think about that. Look and try to figure out how much is each block worth in elevation. I'm hoping what you noticed is that every 2 blocks, we go up 1,000. So every 1 block, we'd go up half of 1,000. So we'd go up 500. So from here, we have 8,000, and then we go up 1 more, and that's where we're at 0. So 8,000 plus 500 is 8,500. So the first part of this question, we found an answer. What was the elevation of the plane at 0 seconds? It's 8,500. And be careful here, we need to do units. Think about what our units are going to be. If we look back over here, we see that our units is meters. So 8,500 meters is the answer to the first one. The first question has 2 parts, and it's very similar to the first part. Now it's looking for what was the elevation at 1400 seconds. Okay, we're going to do this one in red. So, 1400 seconds. So what we're going to do, how we're going to start, is we're going to go to our time, okay? And we need to figure out where's 1400. So we're going across, boom, 1400 is right there. But what we care about is where it is on the line. So what we have to do is we have to go up until we get to the line. And that is right there. Then we look, and we need to see what our elevation was. Our elevation, if we go across to where we were, It's right here. What's the number that represents that block? Remember that each block represents an increase of 500 meters. So, because our line is right here at 1400, it's going to be 1500 meters. Because where our dot is right now, where this red dot represents 1500, and that's where our line is, right here. Do y'all see that? I hope so. So, the answer to the second part of this is 1500 meters. Okay. And then part 2 of this says, at what rate did the plate descend? Okay? There's a very important word here that we really need to define. Rate. I'm assuming that most of you know what that means. If it does, great. If you do know what it means, great. If not, that's totally fine, because we're going to explain what it means. So rate is really just another word for slope. So what this is really asking, at what slope is our line going down? Because our line is representing our plane, right? So for what is our slope when we go down, right? How do we find slope? We remember that slope is rise over run. So what we need to do is we need to find 2 points and then do rise over run. So what we're going to do is we're going to plot 2 points. It can be any 2 points that go through our line. So it doesn't matter what we pick for our 2 points, because no matter what 2 points we'll do, it'll always be the same. So I'm going to choose, we're going to go this point right here, and this point right here. Okay? So what we need to notice is how much are we going down. We need to figure out what our rise is and what our run is, right? So our rise, okay? Our rise is going from here, this point right here, down to here. 2 blocks, right? However, it's not just 2. It is 2 blocks, but remember, each block in this one is 500 meters. So we're actually going down 1,000 meters for our rise. So what we're going to do, we're going to go back to where we were, and we're going to write down what our rise was. And our rise is negative 1,000. I want you to take a second to think about why this is negative, okay? I hope what you realized why it's negative is because we're going down. Our line is going down. It is representing a negative slope. If our line was positive and going up, which is like this, that's positive, it would be positive. Okay? So we found our rise. Now we need to find our run. So we're going to go back up. We need to look at how far we went over. Okay? So we went from this point right here, right? And at that point, we were at 1,400 seconds. Then we went over to this point, and we were at 1,600 seconds. So we need to think about how many seconds is in between 1,400 and 1,600. And a good way to do this is we take our bigger number, and we can subtract it from our smaller number. So if we wanted to do that, we could go 1,600 minus 1,400, and we know that is 200. Or what we could do is we could figure out how much a block represents on our x-axis. So here, when we go over, we know that one block is 100, then it's 200, then 300, and then 400, and so on. So our run for this would be 200. So we'll grab a marker, 200. And the last thing that we need to do, we have rise over run. This is rise over run. The over actually means divide. So the last thing that we need to do is we just need to divide these. And when we do, we're going to get negative 1,000 divided by 200 is equal to negative 5. So the answer to question 2 was negative 5. So that is it for day 1. You can stop this video right now and go ahead and do the Khan Academy exercise that was assigned for Monday. Hey everybody, welcome back. We are now on day 2. So let's go ahead and let's jump right to example 2. So today what you're going to be doing is you're going to be given a word problem and you are going to have to graph what the word problem is describing to you, okay? So the most important part about this is that we need to pick apart the important information in our problem. So let's start by reading it and then we'll pick apart the important information. So a battery with 20% of its full capacity is connected to a charger. Every minute that passes, an additional 5% of its capacity is charged. So to me, there are 2 really important pieces of information. The first is a battery with 20% of its full capacity, okay? And the second part is every minute that passes, an additional 5% of its capacity is charged, okay? So what we need to do is we need to graph this somehow. So how we're going to do this is we are going to start by graphing the y-intercept, okay? I want you to take a second to think about where is... Okay, let me rephrase. At what time will our y-intercept be? So we know our y-intercept is going to always be on this line, right? At what time is it going to be at this line? 0, right? Because as we go across this line, it's going up in minutes. And when we're right here, or on our y-intercept line, or our y-axis, we are at 0 minutes. So, if this graph is going to represent the relationship between battery and time at 0 minutes, so before we plugged in the charger, what percent were we at? It tells us that we were at 20%. So what we're going to do is we're going to graph that. We're going to draw a dot, or we're going to plot a point where 20% is. And that is right here. So, from there, we're going to need to make a couple more points in order for us to make our line. So, the second important part says, every minute that passes, an additional 5% of its capacity is charged. So we need to plot another point so that we can show that. So, what we need to do is we need to show an increase of 5%. Okay? So we need to go up 5 on our y, and we need to go over 1 minute on our x. So that's what we're going to do. So from our 20, we're going to go up 5%. We're going to go over a minute. And that's going to be right there. Do we see that? We went up 5%, up 5, and over 1 minute. Up 5 and over a minute to find our next point. And we're going to do the same thing. And plot another point. We're going to go up 5 and over a minute. And we're going to plot a point right there. And we could continue to do this. And guess what we have just created? We've created our line. So, next thing we're going to do is we are going to graph our line. Boom. There's our line. And guess what? We are now done with example 2. So, you can pause this video, and you can go ahead and do the Khan Academy exercise that was assigned for Tuesday. Alright, good luck, have fun. Hello, and welcome back. It is now day 3. So let's head on over to example 3. Here we go. So let's go ahead and read this. Example 3 says, a young sumo wrestler decided to go on a special diet to gain weight rapidly. W represents the wrestler's weight in kilograms after T months. Okay? And they gave us an equation that represents this. They gave us this equation. W equals 80 plus 5.4T. What does that look like? I'm going to give you a second to think about this. And while you do that, I'm going to write down what it looks like to me. Oh, I think you got it. Boom. Y equals mx plus b. The only difference, though, is that the mx and the b, they've switched spots. I want you to think about if that matters. The answer to that question is, no, it doesn't. Think about it like this. What is 4 plus 5? We know it's 9, right? What if we switch the order? What is 5 plus 4? Guess what? It's still 9. Addition is what you call associative. It doesn't matter the order. Regardless of what comes first, it will equal the same thing. So, this equation, just an equation for a line, okay? So, the question asks, what was the wrestler's weight before his special diet? So, before he started his diet, how many months was he on his diet? It's a funny question, right? I think we know that. He was on his diet for 0 months before he started his special diet. And what do we know his weight was before his diet? We know that it's going to be 80, right? Because what this is saying is that he starts at 80 kilograms, and then after every T months, so every 1 month, he's going to gain 5.4 kilograms, okay? So to answer this question, what was the wrestler's weight before his special diet? Well, we know that. They gave that to us. It's this 80. So the answer to this is 80 kilograms. Boom. I'm going to ask another question just so I know we got this. I want to know how many kilograms would our sumo wrestler weigh after 2 months, okay? So, in order for us to do that, here, I'll write that down real quick. So like this. 2 months. Okay? After 2 months. So, what we need to do is we need to plug that in. We know that T represents months, right? So if we want to know what it is after 2 months, guess what we're going to have to do? We're going to have to plug in 2 for T and do a little math. And what that looks like is we're going to say that W, where his weight is equal to 80 plus 5.4 T, or in our case, T is 2 because it's 2 months. So then what we do from here is we need to go 5.4 times 2, and 5.4 times 2 is 10.8. Then we're going to add 80 plus 10.8, and we're going to know that his weight after 2 months is equal to 90.8 kilograms. So for these questions, just be careful with what it's asking, and you got it. This is it. That's it for example 3. You can go ahead and pause this video, and you can go ahead and do the Khan Academy exercises for Wednesday's work. All right, we'll see you tomorrow. Hello and welcome. It is now Thursday, and we are going to get started with example 4. So here we go. Example 4 wants to know which one of these decrease faster, P, G, or neither. So what we care about is the slope, okay? So the slope tells us which is going to decrease faster. So the more negative it is, the faster it will decrease. Okay, so as an example, if we had a slope of -5 and a slope of -2, we know that the slope of -5 would decrease faster, right? Because the slope is going to be steeper. So as an example, one would be steeper, would be decreasing more. Or one would look something like that, and the other may look something like this. And we know that this line is going down quicker, right, than this line. So what we're going to need to do is we're going to need to find slope for P and slope for G. P, right here. It's this line, right? G is our table, right here. So what we're going to need to do is we're going to need to find the slopes of both. So let's start with P, because we already know how to find the slope for P. So let's zoom in so we can see it a little better. So in order to find slope, what we need to do is we need to find 2 points, and then we need to figure out what the rise over run is. So I'm going to plot 2 points. Boom, right here. And we'll say right here. Okay? So we go down 1, 2, 3, and over 1, 2. So we go down 3 and over 2. So our slope of P is -3 over 2. Okay? So, we found P. Now we need to find G. Okay? So we're going to say G equals. Now let's find that slope. Okay? So, let's go to our table. Here it is. Okay? So, how can we find slope based on a table? Okay? I'm going to show you how. So, we know that slope is rise over run, right? So, in this table, the t will always be the x. Or in our case, how far we move over on the x represents what? Here, how far we went over represented our run, right? So if we go back up to here, we know that t is representing how far over we're going. So we're going to look at these 2 points to find our rise over run. So we're only going over from 0 to 1. So our run is going to be 1. So in our rise over run, it's going to be 1. Now what we need to do is we need to find our rise. Okay? So what we need to do is we need to see what happened from here to here. What happened? How did we go from -6 to -8? Well, we went down how many? We went down -2, right? We went down from -6 to -7 to -8. So our rise was -2 because we went down 2 from those 2 points. Okay? I want to make a quick point here. So, the point I want to make is that no matter what 2 points we chose in our table, our slope will always be the same. So, regardless if we chose these points, or even the middle 2 points, it would still be -2 over 1. So, how we found this 1, it was our run. And because we went from 0 to 1, and that was from 0 to 1, we went up 1. From 1 to 2, what happens? We go up 1. From 2 to 3, what happens? We go up 1. Right? How would we find this negative 2? Well, from negative 6 to negative 8, we went down 2, right? From negative 8 to negative 10, guess what happens? We're going to go down 2. Then from negative 8 to negative 12, we're going to go down 2. So, no matter what 2 points pick, we're always going to have the same rise over run. So let's finish this problem up. So we know that G has a slope of negative 2. So which one of these decreases faster? We know that the one that decreases faster is the one that is more negative, right? If it is a negative slope, it is the one that is more negative. So for us, the one that is going to be decreasing faster is G. Oh, is G. Boom. Because a slope of negative 2 is steeper, like this, it's steeper than P. So that is it. You can go ahead and try those Khan Academy exercises, and if you have questions, please feel free to reach out. I'll talk to you all soon.